Hello students, today we will discuss the topic register and register transfer language. This topic belongs to computer architecture and assembly language. So let's start the topic. So before starting the topic, let's understand the terminology of the topic, which includes the two terms register and register transfer language. So registers आपके क्या होते हैं पहले वो डिस्कस करते हैं. So registers are basically a storage device which is present in the control unit so that you can store your data in the system. Registers को basically आप use करते हैं ताकि आपका जो भी information है जिसको आपको either transfer कराना है और आइदर आप कोई इंटरमीडिएट रिजल्ट है आप उसको स्टोर कराना चाहते हैं तो हम रजिस्टर्स का यूज़ करते हैं. रजिस्टर्स को हम लोग स्पेसिफिक रजिस्टर्स भी हमारे पास होते हैं जिनको हम लोग यूज़ कर सकते हैं. जस्ट लाइक वी हैव डेटा रजिस्टर. द एब्रिविएशन ऑफ डेटा रजिस्टर इज DR. So DR is data register which hold the operand of the memory. Operand means the data on which the further calculations will be done, or the manipulation you want to make, the data will be further manipulated. So that data will be stored in the data register. For this specific registers, we have a table. Now look at that table. The table is this. So in this table, we have register symbols, the number of bits the data can contain, and the register name and the functions. So one by one we will discuss the registers. So the registers available here are data register, which is DR, AR for address register, accumulator, IR for instruction register, PC program counter, and TR for temporary register, INPR and OUTR. In the next column we have described the number of bits each register can store. Like TR can contain 16 bits. DR can contain 16 bits. PC's program counter, it can contain 12 bits. The functions are also given in this table. So data register function is it hold the memory operand. Address, as the name specifies, address register, you can store the address of the memory in this register. AC is a special purpose register, and the synonym for the accumulator is processor register. Then we have IR. This is instruction register. It holds the instruction code. PC means program counter. It will hold the address of the next instruction which is going to be executed. Then TR is temporary register. The temporary word here means that you can store temporary data in this. Suppose we are doing some kind of multiplication and there are 3-digit multiplication. So the intermediate result can be stored in the TR form. TR data, TR register. In INPR, we store the input register, we store the input characters, and OUTR, output register, we store the output characters. These two are the only two registers which can hold the number of bits, which is 8, and the others are 12 and 16. In the next, this is the explanation of each register. Like address register, which is of 12 bits and it holds the address for the memory. The PC, which holds the address of the next instruction which is going to be executed. And the two registers, again, as we have discussed earlier, that there are two registers which we use for input and output. So INPR is for input, INP, input, R is for register. So INPR, input register, which hold 8-bit value. And there is OUTR, out for output, and R for register, which again hold the 8-bit information. This was all about registers. So now we will move up to register transfer language. Register transfer language. Registers आपका वो मेमोरी प्लेस जिसमें आपने डेटा को स्टोर कराया है. डेटा कैन बी ऑफ एनी टाइप. इफ वी हैव यूज्ड डेटा रजिस्टर, you are storing the data of the operand. If you are having an address register, then you are storing the address of the memory in that register. If you are using program counter register, then you are storing the address of the next instruction going to be executed. So these are the registers. Transfer language means now you are transferring the data in between registers and for that you use a particular kind of language. So now we will discuss that. Micro operations we will discuss first, because these are the micro operations which will be performed in the registers. Like माइक्रो ऑपरेशन क्या होते हैं? माइक्रो ऑपरेशंस आपके एलिमेंट्री ऑपरेशंस होते हैं. माइक्रो ऑपरेशंस, जैसे माइक्रो को बोला जाता है कि माइक्रो क्या होता है आपका छोटे छोटे ऑपरेशंस, माइक्रो लाइक मिनी. माइक्रो ऑपरेशंस जो आप लिटिल एंड स्मॉल ऑपरेशंस जो आप परफॉर्म करते हैं ऑन द डेटा, उसको हम लोग बोलते हैं माइक्रो ऑपरेशंस. ये आपके एलिमेंट्री ऑपरेशंस होते हैं. ये आपके जो भी डेटा आपने रजिस्टर में स्टोर किया हुआ है, एक या एक से ज़्यादा रजिस्टर में आपने स्टोर किया है डेटा को, तो उसमें आप इसको ट्रांसफर को और इन ऑपरेशंस को आप परफॉर्म करा सकते हैं. द एग्जाम्पल ऑफ माइक्रो ऑपरेशंस आर, आप कोई भी डेटा को शिफ्ट कराना चाहते हैं, 1 बिट शिफ्ट करा रहे हैं, 2 बिट शिफ्ट करा रहे हैं, तो आप शिफ्टिंग परफॉर्म कर सकते हैं. आप काउंट कर सकते हैं द डेटा इन द रजिस्टर, आप क्लियर कर सकते हैं, आप लोड कर सकते हैं. सो दीज आर द माइक्रो ऑपरेशंस विच आर परफॉर्म्ड. नाउ फॉर रजिस्टर ट्रांसफर लैंग्वेज, दिस इज द बेसिक डिस्क्रिप्शन ऑफ रजिस्टर ट्रांसफर. रजिस्टर ट्रांसफर आप किस तरह से डेटा को ट्रांसफर करा रहे हैं एंड किस तरह से आप इस टर्मिनोलॉजी को लैंग्वेज के थ्रू रिप्रेजेंट कर रहे हैं, कौन कौन से सिंबल्स आप यूज कर रहे हैं टू राइटिंग दैट पर्टिकुलर ट्रांसफर, उसको हम आगे डिस्कस करते हैं. नाउ दिस इज रजिस्टर ट्रांसफर. कुछ बातों को आपको बहुत ध्यान रखना है जब आप रजिस्टर ट्रांसफर यूज करते हैं. ये आपके सारे वो कॉमन टर्म्स हैं एंड इंपॉर्टेंट टर्म्स हैं जो आपको मैंडेटरी है लर्न रखना, बिकॉज रजिस्टर ट्रांसफर आप इसी से रिप्रेजेंट कर सकते हैं. जस्ट लाइक आप हर एक रजिस्टर को हमेशा कैपिटल लेटर से डिनोट करेंगे, एंड इफ यू हैव मल्टीपल रजिस्टर्स देन यू कैन यूज द नंबर्स टू, but the numbers will always be followed by the letter. Suppose you have registers 5, there are 5 registers we have, so how we will write it down? Like R1. So firstly we will write down the capital letter R. It must be a capital letter. It is mandatory that registers are represented in capital letters, and the number will follow the letter, like R1, R2, R3, R4, R5. This is how we represent the registers. Now the next representation of the register is that the registers are always represented in a rectangular box, as I have already highlighted the term that they are always represented in a rectangular box, and the name of the register is written inside the register. We can also divide a 16-bit register into 2 parts, that is from 0 to 7 and from 8 to 15. If we are dividing the 16-bit register in 2 parts, the 2 parts name will be like low order bytes and higher order bytes. Low order means 0 to 7 and higher order means 8 to 15. So this is how we represent. Let me explain this. This is the representation of the boxes, name, number, and how you divide a 16-bit register into 2 parts. As in the A part, I have simply taken a rectangular box. There is the name of the rectangular box, that is R1, which is written inside the rectangular box, and as we have discussed, R is followed by a number, so the number is 1. You can also represent individual bits in the register, like we have represented that in the part B, which is from 0 to 7. In the third C part, we have taken a 16-bit register whose bits are 0 to 15 and the register name is R2. In the D part, we have taken the partition of the 16-bit register into 2 parts, the lower part and the higher part. The lower part is 0 to 7 and the higher part is 8 to 15. We have represented this in the bits form, and we have also represented PC, which is program counter, which will hold the address of the next memory, which will hold the address of the next instruction going to be executed. So this is of 16 bits, and we have divided that into 2 parts, lower order and higher order. And this is how we transfer the data. To transfer the data, we use arrow representation. So in this, you can see that R1's data is got transferred into R2. So whatever the content R1 is holding right now, that content will be transferred into register R2. So after this transformation, when the data of R1 will be transferred into R2, what will happen? जो भी डेटा आपका R2 में था वो आपका रिप्लेस हो जाएगा बाय द डेटा वी हैव ट्रांसफर्ड फ्रॉम R1. सो राइट नाउ R2 इज कंटेनिंग द डेटा which was transferred from R1, and R1 is the source register, so the data will not be changed after the transfer. R1 itself will hold the data, and further the data is also transferred into R2. So this is the symbolic representation of data transfer. This arrow representation is an important part as it will show the flow of the information from which register to which register the data got transferred. As we can see that from R1, which is the source register, to R2, which is the destination register, the data got transferred. Always remember the point that the content of the source register will not be changed after transfer. The content of the destination register will be changed. So this is an important part. Now we have a control function in this. Control function means just like control. Control means you are taking a control of the situation, that whatever will be done, it will be done according to the control which is applied in the situation. So here if you want to transfer the data from R1 to R2, let's understand the term by control function. In this we have a if then condition. If P is equals to 1, what is P? P is a control signal which is in the control section. It is a Boolean variable whose value can be 1 or 0. So P is a control signal in the control section. It will control the transfer of the data from register R1 to R2. So in this if then statement will play a role. If P is equals to 1, only then the data of R1 will be transferred into R2. Now we will see this with the help of a diagram. Now here is this, the diagram. The diagram A, block diagram, represents that the transfer of R1 to R2, the content or the data of R1 will be transferred to R2 only when P is equals to 1. So what is here P? P is here the control function. P is totally controlling the situation, that if right now P is 1, only then you can transfer the data from R1 to R2. In this diagram, we have a control circuit, R1 register, R2 register, and we have a clock in this and a load line. The number of bits will be represented by N. That means how much data or how many bits you are transferring from register R1 to R2 will be represented by N. The load line and the control line are synchronized. That means whenever the clock pulse get activated, the load line will be enabled and further the data will be transferred from R1 to R2. N is the number of bits, clock is synchronized with load line, and both with the synchronous communication and coordination will make the data transfer from R1 to R2. In the next timing diagram, we have represented this same thing with the higher edges T1 and T plus 1. Now, this is the same description of the explanation I have given already, that N is the number of inputs which will be transferred into R2 and will represent the number of bits in the register, and the actual length, if you know the actual length, that you are transferring the data of 8 bits, so you can represent 8 in the number, not N. So if the number of bits are known, then you don't need to represent N. You can simply directly write it down that this is the number of bits we want to transfer from R1 to R2. Next, we have some basic symbols which will be used while the transfer of the data from one register to another. Symbols को हमेशा याद रखना है, because इन symbols के through ही आप हमेशा data transfer को और register को represent करा सकते हैं. The symbols are this. These are the basic symbols. Means always remember these symbols while representing registers, while writing about registers, while making a register transfer. So these symbols are important. The first symbol is letter. Letter आपके अल्फाबेट्स, ठीक है, देन आपके न्यूमरल्स। एज वी हैव ऑलरेडी डिस्कस्ड, सबसे पहले आप लेटर ही लिखेंगे, देन आप नंबर लिखेंगे। डू नॉट एवर राइट इट लाइक 2MAR और 2R, ऐसा कभी नहीं लिखेंगे आप। आपको हमेशा किस तरह से लिखना है, दैट R2 MAR। You can also write down only letters. It is not always mandatory और necessary कि आपको numbers को include करना ही है। आप सिर्फ letters के थ्रू represent करा सकते हैं आपके registers, but you can not represent register only by letters. आपको अगर letters include करने हैं, sorry numerals, अगर आपको numerals include करने हैं, number आपको लेना है तो आपको letter लेना ही होगा। अगर आप सिर्फ लेटर लेंगे ओके फाइन, बट अगर आप नंबर ले रहे हैं 1 2 3 काउंटिंग जैसा, तो आपको क्या करना है, नंबर लिखना है आफ्टर लेटर लाइक R2। देन यूज parenthesis. Parenthesis, as we have already discussed earlier, that while partitioning the data, what you will write down, 0 to 7. So write down those bits in parenthesis, 8 to 15. So bit representation, you can write it down in the parenthesis. Number of registers, you can write down in parenthesis. If you want to partition 16-bit register into two lower order and higher order part, you can write it down in parenthesis. Now for transfer, you will use arrow. Arrow will basically symbolize that from where to where the data get transferred. As we have discussed the example of R1 and R2. So at that time, the data of R1 was transferred into R2. So arrow will denote the transfer of information. As in this, we have taken R1 to R2. Then we can use comma. Comma we will use when you have multiple transfer of data. Like in this, there is 2 transfer of data, register transfer. In these 2 register transfer, firstly you are transferring the data from R1 to R2. In the next, you are transferring the data from R2 to R1. So this is the basic concept and basic idea of what do you mean by registers and what is the terminology behind register and register transfer language. We will meet up next in the class with a new topic, and hope you have found out this topic interesting.